Hello and welcome to another complete Cambridge IGCSE Chemistry lesson, where you'll learn absolutely everything you need to know on topic 6.4 Redox. As always, we'll be following the Cambridge syllabus exactly and we'll learn absolutely everything you need to know for your final exam. Just a reminder that I'm only posting half the topics in the syllabus here on YouTube, but if you want access to the entire syllabus, you can find a link to my Patreon in the description. Also, the slides I use in my videos will eventually be available to download soon after I've finished producing all the videos. Once done, I'll put a link to those in the description as well. Oxidation number, or oxidation state, represents the number of electrons lost or gained by an element in a compound. To indicate the oxidation number of an element, Roman numerals are written in brackets after the element's name. For example, iron can form ions with different oxidation numbers. An iron 2 ion has an oxidation number of +2. This means it's lost 2 electrons and has a 2+ charge. An iron 3 ion has an oxidation number of +3. This means it's lost 3 electrons and has a 3+ charge. Oxidation and reduction can be defined in terms of a gain or loss of oxygen or a gain or loss of electrons. In terms of oxygen transfer, oxidation is the gain of oxygen by an element or a compound, and reduction is a loss of oxygen by an element or compound. For example, when magnesium reacts with oxygen to form magnesium oxide, the magnesium gains oxygen, so it's oxidized. When aluminium oxide is broken down or decomposed to form aluminium and oxygen, the aluminium oxide loses oxygen, so it's reduced. Now, oxidation and reduction often occur simultaneously in a reaction. Such reactions are referred to as redox reactions. The RED stands for reduction and the OX for oxidation. For example, when copper 2 oxide reacts with hydrogen, the copper 2 oxide is reduced because it loses oxygen, and hydrogen is oxidized because it gains oxygen. This reaction is classified as a redox reaction because it involves the simultaneous loss and gain of oxygen. You need to be able to identify oxidation and reduction in redox reactions. For example, which chemicals are reduced and oxidized in the reaction between iron 3 oxide and carbon monoxide? Iron 3 oxide is the substance in the equation that loses oxygen, so it's reduced, and carbon monoxide is the substance that gains oxygen, so it's oxidized. Okay, that's everything you need to know for core, so we'll move on now to the extended section. So oxidation and reduction can also be understood in terms of a gain or loss of electrons. Oxidation is the loss of electrons or an increase in oxidation number. For example, in this reaction, lead loses 2 electrons to form a lead ion. As shown by the ionic half equation, Pb forms Pb2+ plus 2E-. Oxidation number has increased from 0 to +2, so the lead atom has been oxidized. Reduction is the gain of electrons or a decrease in oxidation number. For example, in this reaction, an aluminium ion gains 3 electrons to form a neutral aluminium atom. Oxidation number has decreased from +3 to 0, so the aluminium ion has been reduced. The mnemonic oil rig can be used to remember oxidation and reduction in terms of electron transfer. Oxidation is loss of electrons or an increase in oxidation number, and reduction is gain of electrons or a decrease in oxidation number. Redox reactions involve simultaneous oxidation and reduction, which in this context means simultaneous loss and gain of electrons. For example, zinc reacts with copper 2 sulfate to form zinc sulfate and copper. The equation can be written as an ionic equation by replacing any aqueous ionic compounds with their component ions. For more on this, check out my video on topic 3.1. We can then remove or cancel out any spectator ions, which are the unchanged ions that appear on both sides of the equation. This leaves us with Zn plus Cu2 plus forms Zn2 plus Cu. The zinc atom has lost electrons to become a positive ion. Its oxidation number has increased from 0 to +2, so it's been oxidized. The copper ion has gained electrons to become a neutral copper atom. Its oxidation number has decreased from +2 to 0, so it's been reduced. You need to be able to identify redox reactions by changes in oxidation number. If we know the oxidation numbers of the substances in a reaction, we can determine whether the reaction is a redox reaction. The rules for determining oxidation numbers are as follows. Number 1. The oxidation number of elements in their uncombined state is 0, and this includes the diatomic elements like oxygen, chlorine, and nitrogen whose atoms appear in pairs. In this example, where zinc reacts with copper sulfate to form zinc sulfate and copper, the oxidation number of both zinc and copper is 0. Number 2. The oxidation number of a monatomic ion, which is an ion made of only one atom, is always the same as the charge on the ion. So here I've written out the ionic equation by breaking down the aqueous compounds into their ions. We have two monatomic ions, both of which have a 2+ charge, so the oxidation number of both ions is +2. Rule number 3. The sum of the oxidation numbers in a compound is 0. In other words, they cancel each other out. This means that the oxidation number of both sulfate ions in the equation must be -2. Number 4. The sum of the oxidation numbers in a polyatomic ion is equal to the charge on the ion. A polyatomic ion is an ion made of two or more atoms covalently bonded together. For example, the oxidation numbers of sulfur and oxygen are +6 and -2 respectively. So our sulfate ion has an overall oxidation number of 6 + 4 times -2, which is -2. Now, when writing ionic equations, we eliminate any spectator ions, leaving only those changed by the reaction. So the sulfate ions get cancelled out, leaving Zn plus Cu2+ forms Zn2+ plus Cu. Now we can work out whether or not the reaction is a redox reaction. This reaction is a redox reaction because the oxidation number of zinc increases from 0 to +2, so zinc is oxidized, and the oxidation number of copper decreases from +2 to 0, which is reduction. An oxidizing agent is a substance that oxidizes another substance and becomes reduced in the process. A reducing agent is a substance that reduces another substance and becomes oxidized in the process. In the context of oxygen transfer, in this example, copper-2 oxide is the oxidizing agent because it oxidizes hydrogen, that is, it gives away its oxygen to hydrogen, and is itself reduced. The reducing agent is hydrogen because it reduces the copper-2 oxide by taking its oxygen and is itself oxidized. In terms of electron transfer, in the same example, by writing out the ionic half equations, we can see that copper-2 oxide is the oxidizing agent because it takes electrons from hydrogen. That is, it oxidizes hydrogen and is itself reduced. Hydrogen is the reducing agent because it gives away its electrons to copper-2 oxide. That is, it reduces copper-2 oxide and is itself oxidized. The tests for redox reactions involve the observation of a color change in the solution being analyzed. Two common examples are acidified potassium manganate 7 and potassium iodide. Aqueous potassium manganate 7 is an oxidizing agent that can be used to test for the presence of reducing agents. When added to a reducing agent, the aqueous potassium manganate 7 changes from purple to colorless. Aqueous potassium iodide is a reducing agent, which can be used to test for the presence of oxidizing agents. When added to an oxidizing agent, the aqueous potassium iodide changes from colorless to brown. Well done, you've just covered absolutely everything you need to know on topic 6.4 redox. If you benefited from this video, remember to subscribe to the channel and check out my Patreon, where I'll be uploading the entire chemistry syllabus. Join me there for our next lesson on topic 7.1, the characteristic properties of acids and bases.